Hello everybody, welcome back to another edition of the TeSys Island Training. I'm your host, Leandro Humada, and in this video what we're going to see is the digital and analog IOs that we have on the TeSys Island. So let's go to the presentation. So on this offer of the TeSys Island, we have inputs and outputs, digital or analog modules that we can use on the TeSys Island. So if we go to the next slide, good. This is like the overview of the things that we can do with the TeSys Island. And in this particular case, as you can see over here, we have the digital I/O and the analog I/O. And this particular case is like instead of using the PLC I/O to communicate to these devices, we can put these avatars. This device to read information from the field. In this case, it can be used to start or stop the soft starter, and in this particular case, just to reading some values. Okay, but it's not just that. Okay, you can of course use this as a remote I/O. Instead of having the PLC communicate with another PLC or another I/O, you can use the bus coupler along with the load management solution that we have. Allowed to have also some readings of the inputs and outputs of the system. Okay, so if you go to the next slide, this is what I meant. So the idea of having the TeSys Island technology is about avatars. That avatars are basically like a recipe of a set of configuration that we can use in order to control or monitor a load. So inside those avatars, there are two particulars related to inputs and output, which is the avatar for digital and the avatar for analog. So you can see here in the left side, I have this logo for the avatar that is directly linked in this particular case to this module. So in this case, the module is the avatar. It's just one-to-one. Okay, because when you go into the software somehow we should be able to see avatars but not the device directly, so it can probably create some kind of confusion. Don't worry. So this logo, it means the avatar logo for that specific digital I/O. For the analog I/O, we have this one. You can see this one is a square signal and this one is a sinusoidal signal. But this is not just it. Okay, we have the possibility to have different avatars that requires I/Os. So for example, you have in this particular case motor one direction avatar that has the possibility to control one starter. Okay, this one is going to communicate with the load directly, but we have the possibility to add like a temperature sensor for the motor. So it will add this avatar will be linked to two devices. Okay, so in the previous one here, this two is just one-to-one. On the next one is a recipe called motor one direction, and that recipe I have a temperature sensor, so it puts all that information just in one avatar. Okay, and in this case for the power interface, if I need to add some I/O, I have some I/O additional. Okay, I can check that out. And in this particular case, the latest one, which is the more advanced, will be to have motor one direction, but I have for temperature sensor, and I have the possibility to use local or remote control assignation over there using the digital I/O. So that's a little bit of the idea of the bus coupler of the avatars that we have for this device. So we have two different models, one for digital and one for analog. So how to differentiate that? We have TPR, and I like to think that is TeSys product, DG for digital, AN for analog, the 242 is going to be 4 inputs and 2 outputs, 2 inputs and 2 outputs. In this case, it's going to be 4 digital inputs and 4 digital outputs. And in this case, 2 analog inputs and 2 analog outputs. Then we should be able to see which are the configurations that we have in the software. So this is the device, this little fella. So we have in the top, in the front top, we have some LEDs that allow us to know the status of this device. We have this remote cable that allows us to connect to the avatar to the left. And we have also this that allows us to extend the bus, okay? Or we have the cover. So we protect that part. In the top, we have some terminal blocks that basically, if you have the information over there, you have input 0, 1, and if it's, in this case, it's the analog, but for the digital, it's very straightforward. It's going to be the same. You just need to have the common for voltage, for 0, and the 24 volts, and that's it. Then we have in the back part the possibility to connect with the real DIMM. Over there, you have all the characteristics of the digital inputs and outputs. So, for example, for the analog inputs, you have voltage, current, you have, I just read it in front here, you had PT100, PT1000, you have thermocouples, and then for the outputs, voltage and current. So, the standard. In the front, as I mentioned over here, we have the QR code that basically shows us information of the product data sheet, and we have the tag over there. So there isn't too many things about it. It's just the potential that we need to know about it. So how do we start? I believe I already explained this in the previous videos, but don't worry, it's good to mention it again. So open some more, create offline project, and then here we have the possibility to use the TeSys island. This is one way to do it. You can always create it this way and then import your configuration using the EcoStruxure motor control configuration software. It's an online tool that we have. Then if you are not able to see this, it's because the DTM is missing. Okay, if you're unable to see DTM, and only just one time happened to me that even if it says TeSys island, it has the visualization of the LTR71. It was weird, and I believe it was something wrong on my side of the installation. But if it happened to you, just uninstall it and install it again, or make a repair on the installation. That should be fine. So in order to connect TeSys island, you need the SOMove and the DTM. Once you have that, you just need to register the SOMove, and then that's it. Everything is free at that point. So how do we start this? So basically, let me just move myself to the bottom. There we go. So we have my avatar view. We just need to go to add avatar, and if we go to the device, okay, this is just a device. You have the logo for the avatar digital I/O and for the analog I/O, and it will link it to each of these devices. Okay, then you should be able to see this, that basically there isn't anything else to configure here. It's just I/O. Okay, but if you're using, for example, Machine Expert, it's going to be good if you just change the name to something more close to your application, that you will need to use this avatar name if you use the libraries. So now that you have that, then you just need to go to settings, and the only device that you can configure over here is going to be the analog I/O avatar. The digital I/O doesn't do anything, but just digital input and output I/O doesn't do anything else. So what is important here is to know which are the different configuration that we have. So analog I/O, we just need the configuration for the inputs and the outputs. We have 2 analog inputs and 1 analog output. So here you can see all the different types. You can see the sensor type, thermocouples, voltage, current, all that. Once you have configured this, click OK, and that's it. So let's open SOMove so I can show you this. So my other window, drag and drop it over here. Good. So here in the top, check which is the DTM. Make sure that it's always updated, just for compatibility things, but I believe I've already explained that in the other videos. create offline project TeSys Island, we create the environment for us to configure the TeSys Island of the project for TeSys Island. Here in my avatar, add avatar, digital I/O, analog I/O. Here you can see, for example, something. Here you have possibility to not select anything else because it's just that. Just move myself a little bit. Okay, and you should be able to see something already changed over here. Nothing else to change. Okay, and it changed. Simple as that. What is important is when we go to the settings. Here in the settings, in the digital I/O, there is nothing else to configure. But here in the analog, yes, we have possibility to select which one are we going to use. Okay. So here, that's it. So there is some more things we're going to carry on. I'm going to show you. So let's check. Don't want to spoil anything. Add check configuration those avatars. That's done. What I didn't mention here is that we have this avatar view, and my island I have the physical view. I give us information how to configure it. Okay. And then later you're gonna see some changes here. So now we had the possibility to add the motor one direction avatar, and let's see if we can add this information too. So my avatar, add avatar. Here we have device, load, and application. So in this case, I'm going to use load, motor one direction, add, and it will add the contactor. Okay, so if we want the temperature sensor, we just put yes. Over here, you can see it add the same TeSys product analog 241. Local control, yes, and it will add the digital I/O. If we select OK, we have here in my island how is the new configuration of this. Okay, so if we want to know which one it is, so it's going to be motor 01 contactor. This one is motor 01 analog I/O, motor 01 digital. And here I'm going to put motor 01. Okay. Above my island, you can see here the position. Okay. How everything is linked. You can see that I have for one avatar 3 devices, which is something very good. And this is the concept of having avatars, that sometimes the avatar doesn't mean I have just one device. A combination of devices can be an avatar. So the other thing that we can do is to access to each bit. So something, if you, this case is made for modulus TCP. So in order to access to a specific device information, if you saw the previous video, I showed you that the bus coupler has the unit ID 255. Here, in order to access to this particular information, the unit ID change. We need to change the unit ID, but not the IP address, the unit ID. And the unit ID needs to be the one that is assigned on the visualization that we have on the avatar view. So this is going to be the 255. This is going to be the number 1, unit ID 1, number 2, and number 3. Okay, so I believe I have one demo case here, but it's not linked to anything. Let's see what is in there. So let me just load from the device. And my avatar, well, in this case I have motor one direction, everything linked to one. But what I mentioned here is that we have the possibility to use local and remote control, and in the diagnostics, I should be able to see this, change it. So let me see if I can change this. You can see that it is closed and open on this side. Let me just put the mouse over there. I put it on remote control, in local control. And it's closed. And it's open. Okay, I just wanted to show you that. On here, but the important thing is that each avatar has their own information, and there is a specific way to access the information if you're using any other PLC. And that is what I mentioned here. So in order to access to the information, in order to control and read the data over here, we just need to know which is the unit ID of the avatar, and the unit ID is related to the position of the avatar view. Okay, the first one is going to be the bus coupler with the system avatar, which is the unit ID 255. The next one is the number 1, and so on and so on and so on, which is different from the physical view. Okay, but that will be another story when we want to read energy on all that. Let's go to the presentation and see if I forgot something. No, I believe that's it. So this is it about the IO. I believe the important thing is that we have a specific avatar for the IOs, and then we have an avatar for the control of the load that have the possibility to add modules and can be together just as one, as I showed you before. Okay, so we need to be careful. We need to check the physical view also to match the configuration that we want on the real world, so you don't get any error message on the comparison of other things. Okay, so, and this is it for the module digital IO and analog IO. Thank you very much for watching this video, and I see you on the next one.